Hey everyone, so here's a statistic that really caught my attention. 76% of developers don't trust AI generated code enough to ship it without human review. That's more than 3 out of 4 developers who think AI coding needs careful oversight, and honestly, they're not wrong. Most people are still using what researchers call vibe coding with AI, which is basically an exploratory, trial and error approach where you describe what you want in natural language and iterate until it works. But what if I told you there's a completely different approach that's changing everything? It's called context engineering, and it's not just another buzzword. This is the systematic way to make AI actually reliable, predictable, and production ready. Today, I'm going to show you exactly what context engineering is, where it came from, why it's replacing both traditional prompt engineering and exploratory coding approaches, and most importantly, how you can start using it right now to get better results from AI. We'll cover the common failures that are probably happening to you right now, and I'll give you the exact framework and actual code to fix them. So if you've ever been frustrated with AI giving you inconsistent results, or if you want to build AI systems that actually work in production, this video is for you. Let's get started. Before we dive into what context engineering is, let's talk about where this term actually came from, because understanding its origins helps explain why it's so important right now. The term context engineering really exploded in June 2025 thanks to some influential voices in the AI community. It started with Tobi Lutke, the CEO of Shopify, who tweeted, "I really like the term context engineering over prompt engineering. It describes the core skill better, the art of providing all the context for the task to be plausibly solvable by the LLM." Then Andrej Karpathy, the former AI director at Tesla and OpenAI co-founder, amplified this with his own tweet, +1 for context engineering over prompt engineering. People associate prompts with short task descriptions you'd give an LLM in your day-to-day use. When in every industrial strength LLM app, context engineering is the delicate art and science of filling the context window with just the right information for the next step. What's fascinating is how quickly this resonated. Harrison Chase from LangChain immediately started writing about it, calling it building dynamic systems to provide the right information and tools in the right format such that the LLM can plausibly accomplish the task. Simon Willison, a respected voice in the developer community, said he thought this term may have sticking power because the inferred definition is much closer to the intended meaning than prompt engineering. By July 2025, we saw major blog posts from companies like Zep, LangChain, and LlamaIndex all talking about context engineering. GitHub repositories started popping up with context engineering in the title. The concept was clearly hitting a nerve because it described what AI engineers were actually doing in production systems. The reason this term caught fire so quickly is that it solved a communication problem. When people heard prompt engineering, they thought it was just about writing better ChatGPT messages. But context engineering immediately conveys that you're building entire systems and architectures. It's the difference between writing a good email versus designing a whole communication infrastructure. Alright, so what exactly is context engineering? Think of it this way. When you talk to a friend about a problem, you don't just give them one sentence and expect them to understand everything, right? You give them background, you explain the situation, you provide context. Context engineering is the same principle but for AI. Instead of just writing clever prompts and hoping for the best, you're systematically designing the entire information environment that the AI needs to succeed. You're providing the right information, the right tools, and the right framework at the right time. Here's a helpful way to think about it. Imagine an iceberg. The prompt is just the tip that you see above water. But context engineering is that massive foundation underneath. It's the facts, the tone, the intent, the history, the examples, the constraints, and everything else the AI needs to know. Now, you might be thinking, wait, isn't this just prompt engineering? And I get why you'd think that. But here's the key difference. Prompt engineering focuses on crafting better instructions for individual interactions. Context engineering is about designing entire systems that provide AI with comprehensive, dynamic information environments. It's like the difference between giving someone directions to your house once versus setting up a comprehensive navigation system that can guide them anywhere they need to go. One is a quick fix, the other is a complete solution. So let's break down the key differences between context engineering and traditional prompt engineering because understanding this will completely change how you approach AI. Prompt engineering is about crafting the perfect instruction. You're trying to find the right words, the right format, the right examples to get the AI to do exactly what you want in that moment. It's like being a really good teacher who knows exactly how to explain something. But here's the problem with that approach. It's local optimization. You're optimizing for one specific interaction, but you're not thinking about the bigger picture. What happens when you want to have a longer conversation? What happens when you need the AI to remember things from earlier? What happens when you need consistent behavior across multiple tasks? Context engineering solves this by thinking globally instead of locally. Instead of perfecting individual prompts, you're designing comprehensive information architectures that the AI operates within. You're setting up memory systems, tool access, knowledge bases, and consistent behavioral guidelines. Now, let's talk about vibe coding because if you've ever used AI, you've probably done this. Vibe coding is basically the trial and error. Let me try this random thing and see what happens. Approach to AI. You know what I'm talking about? You type something into ChatGPT, it doesn't work quite right, so you try rephrasing it. Still not quite right, so you add more details. Still not working, so you try a completely different approach. You're basically throwing stuff at the wall and seeing what sticks. And look, vibe coding isn't necessarily bad, it's actually a great way to explore and experiment. It's how you discover what's possible. But it's not scalable, it's not reliable, and it's definitely not production ready. The problem with vibe coding is that it's based on intuition and luck. You might get amazing results one time, but then you can't replicate them. You're constantly starting from scratch, constantly re explaining things, constantly dealing with inconsistent outputs. Context engineering takes all the good insights from vibe coding and systematizes them. It's like the difference between being a street performer who sometimes has amazing shows versus being a professional musician who can deliver consistent quality every single time. Now, let's talk about what goes wrong when you don't do context engineering properly. Because understanding these failures is important for avoiding them. Research has identified four main types of context failures. Context poisoning is when a hallucination or other error makes it into the context where it is repeatedly referenced. For example, if you're having a conversation about Pokemon and the AI incorrectly states that Pikachu is a fire type, it might then start making all sorts of wrong assumptions based on that incorrect information. Context distraction happens when a context grows so long that the model over focuses on the context, neglecting what it learned during training. Research shows this typically happens around 100,000 tokens for large models and around 32,000 tokens for smaller models like Llama 3.1. Context confusion is when you give the AI conflicting information or too much irrelevant information. Research shows that models perform worse when provided with more than one tool and the Berkey function. Calling leaderboard demonstrates this effect. Context clash happens when new information conflicts with information that's already in the context. A Microsoft and Salesforce study found that when information is gathered in stages rather than all at once, model performance can drop by an average of 39%. So let's talk about how you actually implement context engineering in practice. I'm going to show you some real tools and actual code that you can start using today. The first strategy is dynamic context management using a context manager class. This creates systems that can provide relevant information as needed, rather than cramming everything into static prompts. For production systems, you'd want to implement Model Context Protocol servers. MCP is the new standard that companies like Anthropic and others are adopting to standardize how AI systems access external data and tools. If you're building more complex agent workflows, LangGraph provides excellent support for context engineering through its state management and graph-based architecture. One critical aspect of context engineering is managing context windows effectively. When you're dealing with long conversations or large amounts of information, you need context compression strategies. The key tools and frameworks you should know about include LangChain and LangGraph for orchestration, the Model Context Protocol for standardized integrations, vector databases like Pinecone or VV8 for retrieval, and frameworks like Llama Index for building RAG systems. Remember, context engineering isn't just about the code, it's about architecting entire information systems. You're designing how information flows, how it gets prioritized, how it gets compressed, and how it gets delivered to the AI at exactly the right moment. Alright, let's wrap this up. Context engineering isn't just another buzzword, it's a fundamental shift in how we think about AI systems. Instead of trying to craft perfect prompts or relying on exploratory coding approaches, we're building systematic approaches that provide AI with the right information, tools, and environment to succeed. The key takeaways are: first, context engineering emerged from real frustrations with prompt engineering limitations and gained momentum through influential voices like Tobi Lutke and Andrej Karpathy. Second, it's bigger than prompt engineering. It's about designing entire systems, not just individual interactions. Third, it builds on the insights from exploratory approaches like vibe coding, but systematizes what works. Fourth, avoid the common failure modes by being intentional about context management. And finally, use the real tools and frameworks that are available today. The Model Context Protocol, LangGraph, and proper context management classes aren't just theoretical, they are production ready tools you can implement right now. If you want to get started with context engineering, begin by auditing your current AI interactions. What context are you providing? What information is missing? What could be organized better? Then start implementing some of the tools I showed you today. Build a simple MCP server. Try the context management patterns. Experiment with LangGraph. That's it for today's video. If this helped you understand context engineering better, make sure to hit that like button and subscribe for more AI content. Drop a comment below and let me know what you want to see next. And if you're already using context engineering in your projects, share your experiences. I'd love to hear what's working for you. Thanks for watching, and I'll see you in the next video.